All right, geometry students, today we're going to talk a little bit about isosceles triangles. We mentioned them in class the other day, but an isosceles triangle is a triangle such that there are two sides that are the same length. Three triangles on this page are given to you, and they are all isosceles. Those two sides are the same length. These two sides are the same length. And these two sides are the same length. In an isosceles triangle, the sides that are the same length are referred to as legs. The other side is called the base. I have named each of the triangles ABC, and in each of those triangles, the legs are segment AB and segment BC. The base for each of them is segment AC. Now, in an isosceles triangle, not only are the two sides congruent, but the angles that are opposite those two sides are congruent. So in each of these triangles, angle A will be congruent to angle C. And those angles are referred to as base angles. So the base angles lie along the base and they're opposite the other angle, and the other angle is called the vertex angle. So we got base angles and we have a vertex angle. So every isosceles triangle has two base angles and one vertex angle. On page 187, look at problem number 7 at the top of the page. It says the measure of the vertex angle of an isosceles triangle is 80 degrees. What is the measure of a base angle? Well, take a moment and see if you can sketch that. So after reading that problem, I've drawn a triangle. It says that we have an isosceles triangle, so we got two sides that are the same length. The vertex angle we were told was 80, and we're looking for the two base angles. Well, remember in an isosceles triangle, the two base angles are the same. We know that all three angles in a triangle add up to 180. We already have an 80-degree angle that we know about, so let's subtract 80 from 180, and we're left with 100. So these two values of x, whatever they are, they add up to 100, and they're the same number. So what number do you add to itself and get 100? Well, that is 50. So each of those angles would be 50 degrees. If you like a more algebraic approach, then we'd say 180 equals 80 plus 2 times x. We would subtract 80 from both sides and get 100 equals 2 times x, and then divide both sides by 2 and get x equals 50. So either way, just thinking our way through it or solving it algebraically, we get 50 degrees. All right, next we'll talk about number 8 on page 187, and it says the measure of one base angle of an isosceles triangle is 25 degrees. What is the measure of the vertex angle? So we're looking for this angle here. We've got an isosceles triangle, so both of the base angles are the same, because that's true in every isosceles triangle. And now 25 plus 25 is 50, and so 50 plus something equals 180 degrees, because remember, every triangle's angles add up to 180 degrees. So I got 50 plus x equals 180. So we'll subtract 50 from both sides and get x equals 130 degrees. Now I'll take a moment and look at number 9 and give that one a shot. So number 9 also gives us an isosceles triangle. We know it's isosceles because we're told that the two sides are 5 units long. So the legs of the triangle are 5. We're also told that the leg of the base of the triangle is 6. None of that really matters to us because we're trying to figure out what x is, and x has to do with angles. So remember, base angle equals a base angle, so not only do we have 2x plus 3 over here on this angle, but this angle will also be 2x plus 3. And now I'm going to say that all three angles added together will equal 180. So I'm literally just going to list the angles with a plus sign between them. So 3x minus 1 plus 2x plus 3 plus another 2x plus 3 will equal 180 degrees. So now we will combine like terms. So 3x plus 2x plus 2x. How many x is that? And then we've got 3 plus 3, which is 6, and 6 minus 1 is 5. And that equals 180. Now we got a little algebraic equation to solve, so we'll subtract 5 from both sides, get 7 times x equals 175. And now we just got to figure out what do you multiply 7 by to get 175. And one way to handle that is using the old division property of equality. So x is 25. All right, you should now take out some paper and try page 188, number 18 and 19, and then page 189 and 190, 1 through 7, and 10 through 16.